particle is initially at the point with position vector 24j meters. It has an initial velocity of 8 I meters per second and an acceleration of negative 3j meters per second squared. We want to find the following things. But as an overall, the particle is starting up here, and initially it's moving in this direction, but the acceleration is like so, and therefore it's going to have a path that goes something like this. We're asked initially for the time when the particle crosses the y-axis. Well, let's look at the displacement. We know that it starts at 0, 24. Now what follows is the ut plus a half at squared part of this, because remember that is going to give us the change in displacement. So our u is 8, 0. And then the half a is going to be a half of 0, negative 3. And then that will be t squared. And the x-axis means that the y component or j component of displacement is 0. Remember, a point on the x-axis is where y is 0. So in other words, we will have 24 take away 3 over 2 t squared is equal to 0. So 3 over 2 t squared is equal to 24. So t squared is going to be twice 24, which is 48, divided by 3 is 16. And that must mean that t is equal to 4. We then want the distance of the particle from its initial position when it crosses the x-axis. So one of the things we're going to need here is this one. And so Sx, so that's the x or I component of this, is going to be 8 times 4, which is 32 meters. So if this is 32, the distance is going to be the third side of that triangle, so it's just Pythagoras. So it's just the square root of 24 squared plus 32 squared. So we can calculate that. The square root of 24 squared, add 32 squared, is 40. So now we want the velocity of the particle when it crosses the x-axis. So v equals u plus a t. So that is going to be 8, 0 plus 0, negative 3 times 4, which gives us 8 and negative 12. And then finally, what we want is the speed and direction of motion when it crosses the x-axis. So it's going 8 this way and 12 this way. So we would like this and this. And so as far as v is concerned, that's just going to be the square root of 8 squared plus 12 squared, which is 14.42 meters per second, correct to 2 dp. And then theta is going to be the inverse tangent of 12 over 8. So we'll calculate that as well. The inverse tan of 12 over 8 is 56.3 degrees. And that's below I. And of course, the diagram helps explain exactly what we mean there.